Good morning, and let's begin with the interview process. We are basically looking for a Kubernetes and a Helm developer.
Okay, okay.
All right, so let's go with the questions, which uh, which is going to be for like 30 minutes. So that's the aim. And yep. So would you okay? So please tell me something about yourself.
Yeah, so I have almost like 5 years to 6 years of experience in IT. And coming to Kubernetes and Helm, so I've been involved in a couple of projects. So wherein one project was the migration project. So wherein the applications has been already deployed on Kubernetes, sorry, like in bare metal machine. So we have taken
Mhm.
that and then we wanted to convert that into Kubernetes objects and then deploy it onto the Kubernetes cluster. And this process, like we've used Kubernetes objects, but it has to be deployed via Helm. So these kind of activities I was involved, and also like few of the projects wherein like I've involved from the scratch, wherein it is not already deployed on the bare metal machine. So which is
Mhm.
starting the coding and everything, it which starts from the scratch. So I've been involved in those kind of projects as well. Also, I was part of kind of like involved in doing a POC for monitoring Kubernetes and like how we can effectively manage Kubernetes objects. So all these kind of things have worked in my Kubernetes and Helm.
All right, that's impressive. All right, let's go on with the next question, which is more about monitoring. So
Okay.
what are the monitoring solutions which you have used on like Kubernetes platform?
Yeah,
And
so we had actually we didn't choose any one of it. Like so, we were doing kind of a POC. Like we wanted to know what options are better, and like we wanted to compare many of the monitoring solutions. So we had gone for Prometheus and Grafana, and like with that, like after that, we had tried also ELK. So these two monitoring solutions that we have tried. So why? Because in Prometheus and Grafana, what happens? We need to expose the metrics, and we will be able to get only the metrics of the Kubernetes cluster or the nodes. So wherein like let's say you want to get the logs of your pod and logs of your some file you want to monitor depending on the like let's say there is a file. So wherein you create a pod, so then that file will be affected. In that case, if you want to monitor, so Prometheus won't be able to do it. So in that case, we have gone for ELK, and so we were able to get the logs of pods as well. So because Kubernetes is a very dynamic environment, we never know due to what reason pod might go down or what reason pod might restart. So all these reasons we wanted to monitor. So that's why we have taken the ELK and we did a POC on that as well.
yep, exactly. That's good. In ELK, even if a pod is like terminated, so you can get complete logs out of it.
Yeah, yeah, that's
Oh,
correct.
all right, and so what is the difference between deployment,
Okay.
replica set, and the
Mm-hmm.
stateful set? So yeah.
Yeah, see, deployment is basically deployment and replica sets are I can say which one deployment is dependent on replica set. So when you create a deployment, so basically it creates replica set, and replica set in turn it creates pods. So
Mm,
replica set is basically you're defining how many replicas of your application is needed at any
okay.
point of time. So let's say your application is you have defined six replicas. So at any point of time, your six pods, six instances of your application will be up and running. If somebody goes manually and deletes it, again it will create a new pod for your application. So it is basically to maintain number of copies of your project in a layman terms, if I want to say. And deployment, if you want to maintain the versioning and like if you want to roll out the new version and roll back if you have any issues, those kind of management management I can say it's a wrapper to replica set wherein we can manage the deployment versions and rollbacks and updates upgrades, all these things we can maintain by using deployment. And also deployment and stateful set are similar, but the only main like changes. So in stateful set, basically the pod names will have indexes. Like let's say your you are given your pod name as NGINX. So
Mhm.
when you spin up a replica set, when you spin up your stateful set, so basically it will create a pod with the name NGNX0, NGNX1. So the index starts from 0 to 1. And if that
Mhm.
pod goes down, again it comes back, it will come with the same pod name. So it won't change. But when it comes to deployment, so wherein the pod, if due to many reasons, if somebody deletes a pod or it automatically got deleted due to some issues, so then the
Mhm.
name of the pod in deployment, it will be like a dynamic. It will not be the same. And also the deployments is used for web applications, and so stateful sets are suggested to use for database, wherein stateful applications you want to, like, let's say you want to store whatever the pod data in somewhere, so you'll go for stateful sets.
All right. So do you think that the IP address is retained when a pod is deleted in a stateful set?
uh, the name, the DNS name, it'll be the same. Like,
Okay.
I don't think so. Like service, because service is not deleted, right? So I don't think so
Okay.
that does matter, because the DNS name, it'll be the same. But when it comes to like pod, the DNS name will gonna change. So I don't think so there'll be a change.
Okay. Okay. Yep. All right. So let's get on to the next question, which is something like, for example, a pod is not coming up in a node. Then,
Okay.
what is the possible problems, like a list of things which can um, impact this pod, wherein it's not able to like get initiated in a particular node?
Yeah, there are many reasons. So one is because of taint and tolerations. So wherein if a node has a taint, so in that case, so you need to have a toleration like definition in your file, like pod YML or a deployment YML, because if you don't have toleration, so that particular pod might not go to that particular node. So that might be the reason. And also sometimes what happens, so there can be a memory issue as well. So wherein
Mhm.
your
Yep.
machine, sorry.
Yes, yes, exactly.
So the memory issue, it can be a memory issue wherein like you have requested so much memory, which is not, like, let's say your machine has only a 2 GB and you have requested 4 GB. So in that case also wherein like the pod will be deployed. I mean, the pod will be in a pending state because you have requested more than what you have it. So in that case also it might not schedule. And so one more thing is maybe what happens, like assume like you have used a host port 3000, okay,
Hmm.
30,000 or 30,001 or something. So you're
Hmm.
reusing that port which is already used, but you're reusing that. In that case also pod might not come up because the
Yes.
host port is already used. So these are the things. Also sometimes like what happens, silly mistakes, kind of like the image name might be the wrong, so wherein like it is uh, like deployed, it is scheduled on some particular machine, so some particular node, but the image is wrong. Or like if sometimes like the commands that you have given in arguments in a pod YML or deployment
Hmm.
YML is wrong, in that case also pod might not come up. So there are many reasons, but I have told like whichever as like.
Yep. Yep. These are the main ones, is what I feel too. Okay. So moving on to the next one, which I find interesting to discuss about. This can be something related to like auto scaling. So how can you do auto scaling of deployments or pods in Kubernetes cluster?
Yeah, Kubernetes supports two kinds of. So basically, even recently, I got to know that there is concept called as VPA, wherein like there are many types of auto scalings in Kubernetes. So one is HPA, horizontal pod autoscaler, wherein
Mhm.
we before this we need to do like it depends on what setup you are using, whether you're using cloud provided services or you're using your own Kubedium. So if you use your own Kubedium, so then you need to set up a metric server, because whenever we create a HPA, So horizontal pod autoscaler. So it will communicate with a metric server, and the metric server will communicate to API, Cube API, and then it will get the data. So this setup I've tested, wherein like we need to create a HPA. So if you want to auto scale your pods, so then you need to basically you need to create horizontal pod autoscaler. It will take care if the load, like let's say you can specify if it reaches like 50% of your CPU, so then you want to increase the pod count. So then depending on your conditions, so it will going to increase or decrease the pod numbers. So it is like when a particular point it reaches, so it will create a new pod. So this is a concept of HPA, wherein like there is one more concept, VPA, vertical pod autoscaler. What it does
Mhm.
is you are increasing. Let's say you have assigned your pod to use 500 MB of memory. So if your application grows, so wherein it can increase the memory as your application increases. Like when we create a VPA, so it automatically takes care if it is more than, if your application is using more than like let's say 200 MB, so then if you specify your VPA to increase the memory, so then it can take care of it. So it will delete that pod and it will come up with a new pod with the updated the resource definitions. So this is what like HPA and VPA, horizontal pod autoscaler and vertical pod autoscaler.
Yep, sounds good. And all right, so moving on to the next one. For example, a container it's not coming up.
Mm-hmm.
So how do you check? So what is that you would check to determine like what is the problem? Why is the container not coming up? So how would you go about this?
Yeah, basically, basic logging, we can use kubectl describe command and the pod
Mhm.
name if you give. So we can see the minimal, like the last few logs of like what happened to the pod. And if you want to check the container logs, let's say you're executing a couple of commands, and if you want to see commands like the logs of the container, so then you can use kubectl logs pod name and -c. So if you have multiple containers in a pod, then you can give a container name. So if you don't have, then you can use kubectl logs in the pod name. So this is how I can do the basic logging. By I mean basic monitoring, like what has happened inside the container. Or else like when you have some monitoring solutions like ELK, we can go ahead and we can see that like what happened to our pod. So so these are the two ways I might follow to check my logs. Or,
All right. And for example, we need like logs of the complete cluster. I
Mhm.
mean like Kubernetes cluster.
Yeah.
So how do we go about that?
Actually, I don't remember which folder it'll be stored. So there'll be some folder wherein like all the pod information and everything will be stored. Sorry about that. Like I don't remember that particular folder name. So I'm not sure about that. But yeah, so what the process I know. So it'll be stored in some folder, maybe by using filebeat of ELK, then we can transfer it to ELK system, wherein we can see the things in ELK dashboard. So that we can do, but I don't remember the exact folder name.
All right. Um, okay. All right. Let's discuss something more about like in the architecture level. So what are the different components of Kubernetes?
Yeah, there are a couple of objects. Sorry, many components will be there in the master. When you take master and multiple nodes, so there are few components which runs in a node, and there are few which runs unmaster. In master, basically we have controller, scheduler, and Kube API server and HCD. So HCD is basically database which stores the information about your nodes and all your pod information, everything will be stored here. And like when it comes to node, again we need container runtime. So when like docker in master also we need like docker, any container runtime has to be installed. And with that, like it'll have kubelet. So kubelet is responsible, like wherein like to make your uh, container always up and running. So these are the things, and also kube proxy which will be running on your nodes. So and also when you go for custom network solutions like Flannel, Calico, so these components will also be deployed on the nodes and the master. So these are the things. And controller and scheduler is basically which will be helps in scheduling the pod. And if something goes wrong, so these both will take care of like where it has to be deployed, and pod has to be where uh, should be deployed in which node. So all these things will be decided by these two things.
I would like to ask you something more about uh, okay, a difference between Helm
Mhm.
and operator framework.
Helm is basically it's you can see Kubernetes management tool. So wherein in a layman terms, if you want to see, let's assume you have some kind of like so let's say for a project you want to create 20 objects of Kubernetes like role binding and like ingress, deployment and stateful set. So many things you want to create for a single project. In that case, so what happens is for metadata, assume like each object will have metadata, right? So assume like in each metadata there is a like key called project name, okay? And the project name in all 20 files are similar and the same. So to manage this one, so when we are going with a traditional Kubernetes, so we need to like let's say your manager says change it to something else. So then you need to change in all 20 files. Or assume like you keep all the objects in a single file, then you need to update in multiple places. And also like if it is one change, it's fine. But assume like if you want to do many changes, and if a particular value is changing every day, in that case it's better to go for Helm. So wherein Helm is a package manager for Kubernetes, we can manage all these things very easily, and deploying and upgrading and maintaining your Kubernetes objects is very easy by using Helm. So this is what I can say. Helm and operator framework. What I feel is like I don't know exactly what it is, but operator framework is like something customized work you want to do, like anything which is not available in Kubernetes, and then you can use this Kubernetes operator framework, and you can design your own object and you can use it. So this is what I can say.
All right. Um, okay, so why would you choose an operator framework?
Yeah, assume like some work I wanted to do, like which is not available. Like let's say you have some database, and I want to
Mm.
take like let's say you have some master and child, so you want to take a replica. I mean every time the backup and restore here and all, right? Like in child, wherein to be sync with your master and your like child. So in that case, maybe I can go for this operator framework and create some objects and I can use it. So so there are many basically you want if you want to work with Kubernetes operators, maybe we have already created few operators are there. We can go ahead and we can use that. But if you want to do so, so then you need to know a little bit of Golang. So I feel so.
Okay. Hmm.
So those things, any customized objects that you want to create, you can go ahead and you can use that.
Yep. So let's talk something about storage. So what is the difference between local and remote storage and its usage in a Kubernetes cluster?
In this case, you're talking about this volumes, right? Persistent and non-persistent, I guess.
Yes.
So basically, as I mentioned earlier itself, so when you're going for kind of stateful applications, so wherein like you want to store the files of that particular thing, so then you can go out and you can use the remote storage, wherein you can there are a couple of types of volumes in Kubernetes. So we can use EBS, AWS EBS as our storage, and Google Cloud's disk we can use as a storage. Wherein like when you create a pod, so whatever the data is created in that, it has to be merged. Means like there should be a uh, mounting between your Google Cloud disk and this one. So in that
Mhm.
case, like if the pod goes down, still we have a data. Because if you don't do that, like if you don't have persistent volume, so the data which will be created inside the pod is like it's not about like it's specific to the pod lifecycle itself. If you don't have this persistent volume type, so then
Yeah.
when your pod dies, your data will also go. That is where like you'll go for remote storage. You can use EBS and Google Disk and Azure Disk, all these kind of things, and you can use uh, this network file storage also as a remote storage, wherein you're storing your pods file or like stateful applications files in another remote machine. So wherein you can go and you can choose your depending on your requirement, you can choose any one of it. And when it comes to local, so there are a couple of things like wherein we can use volume type host path, and if you want to like use something when the pod is there, only I need that data. So that time you can go for empty directory, config map, all these kind of things we can go at and use it when it comes to local. But when it comes to remote, so you need to choose. There are a couple of types, like I don't remember all, but yeah, you can use persistent volumes in that case. But if you don't want that, if you want to use your local machine, then you can go for these host path, empty directory, all these kind of things.
All right. Okay. So moving on to the next one. Okay. So what are the difference between a managed Kubernetes services like GKE, EKS, Openshift, and standalone Kubernetes cluster?
Yeah. So when you go for standalone like Kubernetes cluster, so what happens that time is you have to manage all the components, and like let's say there is a situation wherein like you have some update. Like let's say you want to update the version of kubelet, so to from particular version to particular version. So then you have to take care of a lot of things, like what are the parts which is running on the node, you should shift it to other nodes, and then you want to upgrade it and take that parts back, and then make other a node as not scheduled, and then do the upgradations on that. So these things has to be taken care by us itself. And also if you want to add any node, so you need to like create that node, and you need to specify like the labels, and the labels comes into like project specific. But yeah, all this upgradation and downgrade are moving the parts, so all these things we have to take care. But when you go for the services like EKS and GKE, so which is cloud provider managed services, wherein you don't need to take care of all these things. So if you remember, I've told like HPA and VPA. So wherein to
Mhm.
deploy, we need to, if it is Kubernetes managed by us with our own cluster, so then we have to create a metric server. We need to do that. But I have observed in the Google cloud provider service GKE, so wherein they'll create the metric server already. So in that case we just need to create HPE. So that kind of like I can say like those services has made Kubernetes setup very easy. So wherein like when you use your own hosted Kubernetes cluster, it'll these upgradations and maintaining the cluster, it's a little difficult, I feel.
All right. Yeah. Perfect. Um, and my next question would be based on like environment. For example, you have like dev, QA,
Mhm. Okay.
stage, and so on. So how would you go about like maintaining multiple environments? Yeah, values.yaml file.
Yeah, so actually, I've worked on, as I said, I've worked in a couple of projects. So in one of the project, what we did was we had taken the help of like other tool, which is called as Ansible. So
Mhm.
wherein we will have the folder structure for dev, it is dev, and QA and like production, wherein we will store all the secret values and values.yml. So in that respective folders, and when we used to deploy it, so we used to deploy it through Ansible. So that time what happens, like we will pass environment variable like hyphen env and the whatever the values that we want to take, And in the charts, so we used to have dummy values.yml. So in the Ansible task, like when we deploy it, before deploying it, so we will take this values.yml and we will replace it with like the dummy values.yml. So that when we deploy it, we will take the particular env values.yml and then we use to deploy it. So why we had gone for Ansible was we were using a concept called as Ansible Vault. So wherein we used to store all the secrets and everything there. So that's why we had gone for that and we have used that. And one more method, maybe we can have multiple values.yml in the chart. And
Mm-hmm.
we used to use the convention like values.dev.yml, values qa.yml. So when you want to deploy it, so then you want to like if you take Jenkins, so he has to select the environment name, and then we used to take that value and pick a particular values.yml and then deploy it. So we used to
Okay.
do these kind of things.
All right. Okay. So let's discuss about few concepts that you might adopt to keep your application highly available. So what are those going to be?
Yeah. So if I want to keep my like application always up and running, so maybe what I'll think of is like I can define more replicas in the beginning itself. So
Mm-hmm.
if I know that if the application is getting more load, and I can create those kind of things, and also I can implement HPA and VPA concepts to make if my memory is hitting like whatever the threshold I have it. So wherein I can use these concepts and I can create a new pods. So that also I can adopt. And with this liveness and readiness probe, so wherein like readiness, make sure until unless your pod is up and running, so I can't I mean it will stop accepting the request. I can use that concept. And liveness probe, if your pod stuck due to many reasons, so I can restart my pod. So that I can do. So all these concepts I can make use of it, and then I can make my application always up and running.
All right. So these are the questions I had for this particular interview.
Okay.
They,
Yeah.
all right. So I guess then that should be it.
Okay.
So
Yeah.
thanks for your
Thank you.
time then.
Thank you. Bye bye.
All right. Bye bye.